Alright everyone, NATO here, and I'm making a different YouTube video today because if I'm going to be honest, guys, I'm an engineer and a scientist. I'm not a video editor. I hate video editing. It's not fun to me. I'm bad at it. It takes me forever. I just don't enjoy it. So I'm trying to come up with some different formats with things that I can like preset up and not edit and just like straight shot. Like, I teach anyways, and I do like webinars and live presentations. I just do better at that. Like, editing videos just takes me like decades and a half, so it's almost just not even worth me doing sometimes, especially when I have a lot going on. So I know some people are skilled and they're like, oh, it doesn't take any time. It's like, I don't care if it doesn't take someone else any time. I have a whole business to run, but I'm gonna try this format, and I would like your feedback on whether or not this format is any good, especially because this is going to be my first sort of like technical recording video of something, and I'm kind of doing it in a similar way that I would do like a live class or something along those lines, I guess. And I've never tried the like camera in corner thing. It's just, I'm not a marketer, I'm not any of those things. I'm a data scientist who works in cybersecurity and runs a company. So this is what you get. I'm gonna just rant now. So I've been working on this home SIEM project, and I've talked about it in other videos. To give you an idea, like, I'm using the Raspberry Pi, which is on the screen right now, and I've shown it in a few videos, but I'm just building some different things, and I'll talk about why, what they're going to do, how it works. And something that I want to talk about first is the fact that the Raspberry Pi is a very different platform from kind of how it started, I guess, in a lot of ways. And first, I just want to show you guys why I think the Raspberry Pi is such a helpful platform for especially like home security, home development, and even like small business. And there are also enterprise business applications with this new model that could be put into place. I haven't spent a significant amount of time testing on things like enterprise solutions. I've been testing for like home solutions and small business solutions with the Raspberry Pi 4 platform. So I've talked in my video where I dug up my old Dreamcast because I learned how to hack on the Dreamcast, and not just that, it's just something that I learned networking on. I learned how to use basic command line and things like that with the Dreamcast, which sounds strange, like scripting and things, because it runs a version of Windows. It's kind of like a limited version of Windows. Like I said, someone could correct me. I think it's Windows CE. Someone else knows exactly what that operating system was. It's like, this is something I messed with in like around the year 2000, 2001. So I didn't know what I was doing back then. But now, when it comes to other people who want to learn some of the things that I've had the opportunities to learn, there are affordable options for a change. The Raspberry Pi, the reason why I love it is because for what you get out of it, it's affordable. If for a change, there's no excuse to say that, oh, well, I can't afford to learn this stuff. Even the Dreamcast was hundreds of dollars. I got it for a Christmas present. I was a kid. But the Raspberry Pi, you don't need hundreds of dollars to do something, anything. And if you're a homeowner or something along those lines, or you have a home that you live in, that you have access to the router and things like that, like if it's an apartment and maybe you have a roommate, some of you with a roommate, it might be your roommate's equipment. Get someone's approval for things. Or like if you're living with your parents and they set up all the hardware, like ask people things. Obviously, if it's family, of course you're going to just do whatever you're going to do because you'll talk to them or not talk to them. Everyone's family operates differently. But when it comes to like roommates and people like that, or in some cases, some of you are using, say, like Comcast will send you their own router with all these strange things on it. So if you don't have complete control over all the hardware in your home environment, there's still things you can do with the Raspberry Pi without even having full control over, say, like your home network. And I'll be talking about that But the affordability is the big piece here. The affordability for just the amount of power you get. Some things to know about hardware is, and also kind of, I guess I've never really talked too much about what I've done outside of I say that I built SIEM and things. I created a number of things, one being, well, I'm just going to be lazy and just Google it real quick. Something called Logarithm CCF is like a technology that I engineer. Now, this is Logarithm's technology. I'm not saying that I own this. I'm not trying to claim rights to Logarithm's stuff. I built some very nice tools and solutions for them that have been helping them win awards and things like that. And I worked with a team of 3 people at Logarithm, and I was the scientific lead in terms of the science of how this works. But there's this thing called CCF, and that's a logarithm solution. And for most people, this sort of thing is not useful for you unless you're trying to get a job or work for a business. Like, this isn't going to help you in your home. Not really. But to give you an idea of what I do and what SIEM is and things like that, and like why I have fun with some of this stuff, is when I worked in the field, there was a technology that I had started developing with a tool called Kaseya and then some email and whatnot, and people who've worked with me know what this is. But we had somewhere over, I want to say like over 100 clients at the time that we managed their networking stuff. And yeah, and it was so much information that it was like so hard to keep up with events going on at these clients. And we had to deal with disaster recovery, incident response, like all this stuff. I mean, you go down this long laundry list of all these things that would go wrong. There's always something going wrong all the time, like constantly. So the problem was that, you know, if I'm trying to watch like 100 companies on a daily basis, I needed a way to centralize it. And so we would track logs from things and then try to get all of the logs into the same like data structure, and then set up like email alerts with those. So if something bad happened at any client's environment, we would know what's going on, and we could react and respond and take care of things without having to hire like 500 people to, you know, take care of all these little things. Well, 500 is an exaggeration. If we're working with like 100 companies, like we don't have to go out and hire like 20 people to help us take care of the volume and manage that. So your home is another situation where businesses, they have all these needs where it's like they have compliance needs where they might have HIPAA, which people have heard of HIPAA and things. And then GDPR is a new compliance that is something that launched in 2018 for it's one of the world's first data protection, like pure data regulations for data law and so on. And then HIPAA is for, you know, health law. PCI DSS is for payment card information and stuff like that. And so companies have all this stuff. They have to manage user health information and HR information. All that's HIPAA at the end of the day. They have to manage like credit card information and protect that stuff. You know, they got to manage data regulations and anything associated with data privacy and all that. That's a chore and a half. And then even HIPAA has a separate compliance called high tech that's a part. It's a mess. It's because we just have too much data. We have too many things going on, too many devices, all this stuff going on. But there's a way to bring it all together so you can look at all the devices. Like you can look at information on a cell phone and see, make sure, like if someone's trying to hack a cell phone or something, and you can, you know, see what's going on like 50 or 1,000 or however many Raspberry Pis all around the world. If you wanted to configure something that you could do that with, you could. And, you know, at the same time, you know, the approach is something that hackers use to go and farm information from multiple locations, where they send out things that collect information from, you know, hundreds of systems from around the world. Well, the good guys do that too, but the good guys use it to try to protect you and not attack you. It's kind of the same thing in the opposite sense of the word. And the reason why the Raspberry Pi is so exciting to me, because everything starts with hardware. You can't really do anything with hardware. When you get to the internet, Google's run on hardware, believe it or not. The cloud runs on hardware. All of it runs on hardware. And the thing that a lot of people just don't know that you guys should know is that hardware is the same. I'm not going to like teach you guys a class because I don't have patience for that sort of thing, and my YouTube channel is not necessarily for teaching, so this is like my creative space, and I want to talk to you guys about like the stuff that I'm building, and you guys can build this stuff too. I'll probably go ahead and start putting up a lot of gear in my shop so that anyone who's like, oh, this is sweet, I want to build things too, you can just like buy the parts. But with the Raspberry Pi, all systems have a processor, and all systems have RAM. These are some things that systems have. And then, of course, systems have inputs and outputs. So people have heard of USB. There's different standards of USB. There's USB 2, USB 3. Some people may or may not know that. Doesn't matter. Ethernet, some people may or may not know what that is. But then even Wi-Fi is an input. That's a wireless data input. So every system in existence, it doesn't matter if it's a Raspberry Pi, your laptop, a server, a cloud infrastructure environment that's architected with hundreds of thousands of servers. Doesn't really matter what it is. They all have processors, RAM, inputs and outputs. And the part that's important behind that is because the stuff that goes into how things work generally works the same way, because our current technology processes in binary. Everything operates in binary, and because everything processes in binary, that means that if we move on to something that's even smaller than a Raspberry Pi, which this is a Raspberry Pi 4, that is, this is a Raspberry Pi 0, and even a smaller Raspberry Pi has a processor, and I don't remember which one of these modules here is RAM, but one of these modules is RAM. But it's got a processor too, and it's got RAM, and it's got inputs and outputs. So we have all these inputs and outputs on this other smaller Raspberry Pi, and these things are tiny, guys. This one right here on the screen is smaller than this one, which you can see how small it is. It's not big. It's smaller than my mic. I mean, you could build a mic with it and then 3D print a mic, build a microphone with the Raspberry Pi. Now, you could build a wireless microphone with the Raspberry Pi and use the Raspberry Pi as a wireless module. Anyways, I could go on and on and on and on and on, because this microphone deep down inside of it has a PCB in it, because it's not going to work without a PCB, especially because it has a USB-C input right here. So I'm talking into a USB-C input that's going into the mic, which means that this mic has interfacing data. And it's a little... Yeah, anyways. It has a processor, it has RAM. This mic. This cell phone. This keyboard actually has a processor and RAM in it. And because hardware is hardware. And when you start to realize that, you can take things apart in your house. Headphones, same thing, same stuff. And then when we go into other things, something that a lot of people just don't necessarily realize or maybe don't think about is, you hear about these like PC gamers and people who make PC games and things like, or not PC games, there are people who make games, but people who are just like these hobbyists, and they'll go and make this gaming computer and buy a motherboard. Some of you are those types, and I like doing that stuff. Something that people don't realize about that is it's the same thing as everything else. And so the education that people get out of building their PC gaming rigs that they're not ever registering, you don't think of it as, oh, I'm learning so many things right now. People do this. They're like, man, I can't wait to play this set this up and turn it on and run it. Some people like putting the parts together, but people are excited about the end result. And it's the same thing with businesses. So building a gaming PC for people, you have to go, and while it's different from the Raspberry Pi where you have just a board, you have to add a CPU processor, but you have to put a processor in a motherboard for a PC game, even if you have to buy it separately. Just like the Raspberry Pi that has one built on it, which goes down to, why is the Raspberry Pi so painfully affordable? The other one is, not all RAM is made equal. Some RAM is much slower than other things, and when we're talking about processing a lot of information, RAM speeds matter, processing speeds matter, and other models of the Raspberry Pi simply don't have the power to manage enough throughput to do things like, receive data from 20 devices floating around your house. Or some people have, family members and stuff like that, and you'll see 200 devices in a smart home. In a smart home, you'll see 500 plus devices, depending on what people are doing in their smart home. And if you're running a smart home, like, these smaller devices simply aren't going to be able to collect information from a significant amount of sources. It's just going to get crushed. The RAM's not a fast enough RAM architecture. For those who know the difference between RAM, this runs on DDR3 RAM, I believe. I could be wrong. It could be like DDR2 or something. But whatever the RAM architecture is on this, doesn't matter, is that it's just not as fast. And that's not important for certain tasks. But when we want to receive a lot of data from a lot of things, everything, I'm talking about everything, you want to receive all the data from all the things, you need to have a little power. Yes, you need to have a little power. So, anyways, if I go back to this, so the gaming machine, inputs and outputs, it's the same thing, guys. The only real difference is people just stick different speed modules on here that are faster for the bigger machinery, and you can put different speed processors on these larger machines and stuff. But even if we move all the way over to like server architectures, you start to even see some servers where they have multiple RAM lanes, and then they have multiple CPU lanes. And so the type of RAM that can run on a system is dependent on the configuration of an entire system. And so if you understand like how to work with hardware, it's the same no matter what you're working with, to an extent, outside of the fact that things just become faster and more robust and more advanced, and it's basically just like bigger and faster, bigger and faster. So if you can do anything on a Raspberry Pi, it's probably even easier on server hardware. I'm recording on server architecture right now, and it's snappy, it's fast. I can do video editing and stuff on it. I can do all this stuff, but at the end of the day, like, I can just standard stuff like browsing and just looking at a few videos and stuff, like the Raspberry Pi can do all those same things. And something else that's good to know is servers oftentimes, like enterprises, like even just having this many resources on a board, when I built Enterprise SIEM for like this sort of thing right here, guys, this is like a multi-million-dollar solution. This is not, you don't pay $1,000 to put this together, or like $2,000 to put this together. Some companies might be able to do that with some custom stuff, but it's still not going to be the same. With SIEM, like even on the low end, some of the licensing just to like get some of the put things together, it can cost development resources, staffing, labor, all that stuff, like $10,000 just to get one of these things going. SIEM implementation for a business, and when you start to see businesses that need the CCF is really for companies that are making hundreds of millions or hundreds of billions of dollars. You don't need a multi-billion-dollar solution for your home. So all the things I know are overkill for 100% of whatever you guys need to do. You don't need to know anything I know. Not really. There's not much point in me teaching it to you unless you wanted to go and build some of this stuff. And like, if anyone's curious about what Logarithm is, I don't know. You can go to Logarithm's website. But this is just where I learned a lot of my advanced knowledge. I learned at other companies too. And you can look at my LinkedIn. It's just that in terms of like my most high-end experience and things around the world and all that stuff, it's where I spent time developing like dedicated ground-up SIEM, like from scratch, for the most part. There were other people there, so you have a whole team, and they put some packages together. So it's not like I'm doing everything by myself. I'm one of many. So there are a lot of people who know what I know, but for the sake of what you guys need to know, just to do some stuff, you don't need to know what I know. So I wanted to sort of chart out what, how this stuff works. Because first, you just need to understand that you need to have relevant hardware that's going to be able to set up a device that would let you look at all the things in your home. So yeah, SIEM, it's just a technology that lets you look at as many things as you want. So and then that's up to you how many things you want to look at. And it's SIEM is a technology that you put together to just create visibility to look at whatever you're trying to find on your network. And you can set it up to automatically do things. You can set up SIEM to make it to where anytime you have a certain computer automatically crash, you can have the SIEM automatically try to turn it back on. I mean, I don't know why you need that, but like smart home devices like your Ring doorbells and stuff, you can send data from like your Ring doorbells and your security cameras to generate alerts from like certain types of activity on the cameras, things like that, like whether someone's trying to hack the camera or certain types of activity outside. You can collect data from baby monitors and make sure that there's no one trying to hack baby, because people have started hacking baby monitors and things like that, which is an uncomfortable thing to think about. And with SIEM, things aren't invisible. Without SIEM, anything in your home, smart homes, just like invisible. Yeah, and your business. And on one end, some things are really hard to find. So finding something threatening in your environment is still a needle in a haystack scenario. The experience, like especially for those who are trying to be professionals in cybersecurity, in cybersecurity, you really just need to know how to know what's going on in a network, be able to deal with reconnaissance, and like if there's a threat or something, be able to clean it up, identify it, target it, neutralize it, set up things that might help you identify threats, all that stuff. And it's such a purple team thing because you can even use these technologies for pen testing. I've done pen tests even using SIEM platforms, and it's funny because you can build pen testing packages and then automate them with the SIEM. And then you can deploy, so like you could pen test with the SIEM where you set up like a master Raspberry Pi, and then you network it with other Pis somewhere, or other Pis on a network like a DMZ. Those of you who know enough about networking who know what a DMZ is, most of you probably don't who are watching my video, can plug like a Raspberry Pi and a DMZ, have one that you're doing your general work on, put them in different parts of a network, and you can put different packages and payloads on all of the Raspberry Pis, and you can set up libraries to say like whenever certain things are identified on this network that you're pen testing, like launch this package, execute this package, and that's like straight up automated pen testing. You could just like make a SIEM, and the building it would be a chore and a half. I don't know if anyone ever wants to build a pen testing SIEM with me. Talk to me. I'm actually serious about that. Well, I'm down to jam with you. I don't really like developing the code parts of it, but the warehousing and the data warehousing and the structuring of all that stuff, that's my stuff. I code too, but like it's not the exciting part to me. And I've met pen testers who are like, yeah, this is awesome, and that's how I feel about SIEM. So I'm like, this I think is fun. So someone else who thinks the other stuff is fun, we can talk. But this is what I think is fun: is the data warehousing, the structuring, making sure that the data moves quickly and efficiently, and making sure that all the data is together and organized, and looking quite nice so that you can figure out what's going on. And I'm going to show you some of my home SIEM stuff too. But let me first talk some architecture. Let's get into it. So if we have, say, like a Raspberry Pi 4, I'm going to say square, and then we're going to say circle, say equals, so we're going to say Raspberry Pi 4 on one, and then we're going to say zero W on the other. So the Raspberry Pi 4 is just the more powerful module, and Raspberry Pi Zeros are a not as powerful module, but if you're just trying to do basic things, that's all you need. That's showing up a little janky looking. Let's see if I can make that look a little better. Let's see, edit. So that this video is not too hard to watch. That's better. Okay, so I'm going to say squares equal Raspberry Pi 4, and circles equal Raspberry Pi 0W, and then we're going to say that x equals home device. All right, so I'm going to make a little chart. Some things to know about SIEM is it's kind of similar to construction. I guess we could compare it to building a fence right now. In terms of its application, I wouldn't compare it to building a fence. Like a firewall would be closer to like using a network fence. But in terms of building SIEM, I've had people be like, oh, can you give me a step-by-step guide on building? There's not really a good way to step-by-step build SIEM. It's more of a methodology, because it's like if someone says, hey, I'm going to build a house, you could give someone a very specific house architecture, and if they feel like following that exact house architecture, they can. So that's a thing. And when houses get mass produced and things like that, that's what people do. So there's a person who creates the blueprint, and then there are the people who follow the blueprint. So I am in the business of building blueprints, because someone has to build the blueprints for things to get built. And so instead of giving you guys step-by-step guides, I'll eventually get around to blueprinting for you guys, because we build houses with blueprints, not step-by-step guides. And because we can use blueprints to build houses, we can kind of use our own version of a blueprint to build SIEM. And you know, it's a similar thing as like, if you know how many rooms you have in a house, then you can have an idea of how many doors you're going to get. If you know how many devices you have that you want to collect data from, then you can figure out how much power you need. Think about it that way. If a house has 4 rooms in it, and you want to make sure, like bedrooms, you want to make sure that those bedrooms, building a house, you want to make sure those bedrooms have doors, then get 4 doors for the 4 bedrooms. The Raspberry Pi, it's not as straightforward with data science. But let's see, how can I put it? Yeah, it's a similar comparison. So you just need more power. You need more power if you have more devices that you're going to be sending information about your network into a Raspberry Pi. But to get started with things, you can build a simple data center with just 2 Raspberry Pis, and then if you wanted to get even fancier, you could add some Raspberry Pi Zeros. And then if you wanted to make multiple Raspberry Pi Zeros operate as one together, you can create this thing that's called a cluster, where all of the Raspberry Pi Zeros will more or less think that they're the same system, and then they can network with the Raspberry Pi 4s however you want, and then you can make it to where anything you plug into one Raspberry Pi Zero in one part of the house, you know, is accessible from any other Raspberry Pi that you Zero that you connect something to from around the house. And then if you wanted to cluster a Raspberry Pi 4 into that or something like that, you'd get inputs. But I wouldn't recommend clustering separate hardware with different hardware ratings with each other. So I'm not going to talk about why that is, but first we need to have like the heart of our SIEM, of our security information. I'll just write out what SIEM is. SIEM equals security information event management. This is cool stuff. Okay. So we are creating, I'll just put it in this corner. That was great. That's a good place for it. Whatever. Ha. Okay. So we have one Raspberry Pi. And then we are going to need another Raspberry Pi. And I'll tell you what I've been putting together for just like a starter blueprint on, you know, for anyone who's trying to figure out like, okay, if I wanted to build a home SIEM, what am I going to build? So 2 Raspberry Pis, and I'll tell you what we're going to put on these things after I start with this, but this is the beginning. Then we need a way to get data from devices, so we need to have devices that we want data from. Just make a few X's, and I'll give them a few like labels. And so we're kind of thinking of like smart homes, right? Because, or even if you don't have a smart home, you can still learn from doing this. But smart homes, it's like you don't know what's going on in your environment. Like if you don't have something to monitor everything that's going on. So we have some X's over here, and some X's over here. Maybe one is a cell phone, and then one is a Macintosh computer, whatever, well, I'm not even going to try to type the rest of it. So it's a Mac computer, an Apple, or whatever. And then we have Windows right here. And then maybe we have, let's see, Alexa. And then we have a Ring door camera. And then you can build a motion sensor if you want. So maybe you built a motion sensor. I'm building a motion sensor. So maybe you want one. I don't know. And it's cheap to build a motion sensor with Raspberry Pi technology. So if you want to build a motion sensor, you can. And you know, I'd build that with something different. So I'm just gonna say that's not a home device. I mean, it's a home device because we're building a device that's a home device. All right, instead, that is a Pi 0. And then let's say that you have something that you just want to use to kind of like forward certain types of data to your system. Then maybe you get another Raspberry Pi 0 and you use that as a data forwarder. So this is getting toward the kind of architecture that I would want to use. So we have two Raspberry Pis, 4s, and they need to be 4 gigs if we're going to be ingesting data. One doesn't necessarily have to be, but then the next thing we would probably want to do, especially if we're talking about security here, is we are going to install a Pi hole and VPN on one Pi, because home VPN is helpful these days. I strongly recommend it. I strongly recommend it. Strongly recommend it. I also recommend multi-factor authentication, but this is very important right now. So you can build that with Pi, and then we need to do something else. Let's see. All right. So we need to put something like, I'm not going to talk about elk stack right now too much, but you could put something like elk stack here. But because we're working on the Pi, I would strongly, there's reasons for this. I don't feel like explaining the science behind it. If you've had a class with me before, you already know some reasons why that is. Let's see. Specifically, I don't know. Docker is a little. Docker. I've tested Docker for containerization with the Pi, so I know that one works. So annoying that that S is there. Anyways, that S is going to hang out down there. It's elk stack and Docker containers. And then there are a couple of ways that we can collect data. We can either have things send data straight to... Oh yeah, I forgot that there's this pointer. Like, this thing's pretty cool. So, I forgot I can just like highlight things like, Raspberry Pi 4, blah, blah, blah. I like this thing. So there are different ways that we can sort of start collecting data, and this laser pointer is super handy. Because what we can do is we can either have all the data just go straight to ELK, and we can just be like, send all the data here. So much data, right? And, you know, in the beginning it wouldn't be that much data, but as you start adding things and you start needing more storage, oh yeah, we're missing something here. That's okay, I'll add that toward the end, and I'll talk about that. But anyways, we gotta have something that collects the data. So you don't want to have, you have to have at least one Pi designated to collecting data if you're using an architecture like this. You don't want to just be like, I'll just send data to either Pi or something along those lines. The Pi hole already is generating data, and so it's got to send its data somewhere too, and it's got to send its data to a database or a data frame structure, which ELK-Stack is a data frame structure that anyone can build, and it's open source, so anyone can do it. You can do it today if you want to. Go build an ELK-Stack and see what it's like. You can do exactly what I'm talking about today if you wanted to. Or you can wait for me to put together blueprints and guides and things, and then I'll put my shop together and give you like things that I've tested. That way you don't have to do all the testing yourself and bang your face against walls and things. Walls and things. So, back to the pointer. This Pi hole in VPN, it's going to be sending its data over here to this data structure. This thing's just going to be pure data. So the other thing that we're going to do with this is we want to get as much capacity to receive data as possible with this thing. So we want to overclock it. I am testing the stability of overclocks right now with the Raspberry Pi at 2.0 gigahertz. So that I can see like how can we stably ingest data. And we only need to overclock one over. So we only want to overclock one. We don't want to overclock all of our stuff, because overclocking can introduce instability and other things. If someone really wants me to talk about overclocking, that's a thing all by itself, and that's more complicated than is worth getting into in this video, but just know that we need to have a way to better process data, so you can overclock this to get more power. And then a forwarder is something that helps us get data over. So if we have any devices that are kind of hard to get data from, and we need to like consolidate that data to send all of it together over to our data structure, then we can get a Pi 0, and we can have devices that are kind of hard to get data from, where this thing's pure goal is to just collect data, and then it's going to forward that data over to our overclocked device. So then if I were to draw that out, our data paths here, then we have information coming from some devices. It doesn't matter how you send this. It's like building a fence. If you're building a fence, you can't just give someone a step-by-step direction and like, step one to build a fence. You can give them step-by-step directions on certain parts, like here's how to install this particular type of post. So that's kind of how I have to do, is like, here's how to set up this post, here's how to set up this post, and we're talking about, you know, if it's like building a fence, then it's like, okay, we have these different posts. And so setting up a forwarder is one task. Setting up an ELK-Stack is one task. Setting up a Pi hole is one task. Setting up a VPN is one task. Configuring Alexa to forward, one task. Configuring Ring to forward, one task. And then you want to know where things are going, but you can plan that out ahead of time. Because I've done this stuff, I can just mock it up, and it's not much for me to think about. You want me to make videos on specific things, just tell me. Otherwise, these other things just send data all the arrows. All of these things send their data over into the forwarder if you want, and you could alternatively have every device go to the forwarder if you felt like it, and you could just have a series of forwarders just to have something that manages where your data goes. There, like I said, I can talk about different videos on why you do different things in different ways and all this stuff. SIEM is such a modular technology that it's like, Yeah, it's not one where you can just give people step-by-step guides and we're like, here's how you build this exact, because everyone's house is different too. Because for me, I've got to build a motion sensor, and I got to figure out where I want to mount it, where I'm going to put it, and then things like, you know, I got to think about what kind of router I'm connecting all this stuff to for my own system, and then I'm like, okay, well, what kind of, my devices are very specific to me, your devices are very specific to you. But I'll show you a little bit of what I've been putting together. I have to be careful what I show you guys because I am a cybersecurity professional, so I do think about privacy because that's important to me. And this is sort of like an experimental thing right now because this is just me testing and stuff. You can see my temperatures are it's actually pretty warm today. It's because this room's pretty warm right now. I guess it's not too hot, but it's getting a little warm. Memory usage is pretty reasonable. But this is a Pi hole. And something to know about it is if we're trying to build security information event management, then we probably need to have something to help us manage our security events. Like something to help us generate some security events, especially something that's kind of oriented toward something that we can set up without a whole lot of complexities. Something to know about the Pi hole is, let's say that you don't have access to your own router, no biggie. As long as you can connect to Wi-Fi, and as long as you can connect your Pi hole to the same network as your other devices that you want to protect, if you have Ethernet and things like that, great, you can go about different connections. You just want to network these things. However, your environment is capable of being networked, which, once again, we can make videos on all these very specific things, but there's just not enough time in a day sometimes to get into all this stuff. If anyone really wants to get into it, like, join one of my paid classes. If you pay me, I can do things immediately, because it's like, you know, I got to prioritize bills. When bills get paid, then I can tell people whatever you want to know. But I do have classes and programs and stuff like that. I teach at places, and then I don't really have classes for my company. We're kind of focusing more on becoming more of a DIY presence, and we do B2B consultation and support and stuff like that. So we make most of our money B2B, if I'm going to be honest. And then we use the B2B to basically allow us to have the funds to provide free things for people. And because that's the part that I have fun with, like the trainings that I put on YouTube and stuff. But I can't, I'm not gonna like make dedicated classes that I'm going to be selling in my class. If anything, I have a Pi Hacker job simulator that's available, and that's more of like an experience. So I sell experiences to consumers. Businesses, I sell, you know, what they need. So if you're running a cybersecurity program, I'll help you figure out how to set up a SOC, get your cybersecurity program going, or if training is your thing, then I'll help you do the training. So I do, or both, but either I train or I help you get your stuff running. And then for consumers, I mostly train. Businesses mostly come to me for training, consulting, stuff like that. For consumers, it's not my main market, but I'm kind of seeing what you guys might actually enjoy buying and participating in and stuff like that. I'm starting a community around the DIY stuff, and Pi Hacker is where I talk about, you know, that's a class where you get to build the stuff and I give you the science and you get to apply the science. So it's like an applied science lab where you simulate what you'd be doing with the sciences in a job. So it's just a hands-on applied science lab. But I'm going to be releasing some stuff for home SOCs, so you can have all the stuff. And then my between my YouTube videos, which are free, you can take my YouTube architectures, or if you see a YouTube architecture, you're like, oh man, I want to build that, and then I'll just put my the parts so that you can just go find it without having a huge pain, and then I'll have extra guidance and stuff like that, and then give you guys support so that you can build your home SOCs, or for small businesses, because small businesses need this stuff too. But this is Pi-hole, and all you really have to do with these is follow the documentation that they produce, and it walks you through on their website, if you go to their website, how to set it up, and you point DNS configurations, which you'll learn what DNS is if you don't already know what that is, toward the Pi-hole. And once the Pi-hole is connected to the network that other devices are connected to, then you just have all those devices and configure their DNS to go work from the Raspberry Pi. And then you can also configure a VPN. I know you can use like OpenVPN on the Raspberry Pi, And you can make this accessible from anywhere and also protect your home at the same time. So VPNs allow you to leave your home, connect to your VPN from anywhere. Like you could be working at a coffee shop and you just want to get out of the house. Connect to your VPN, and not only is your security there, but you can access all your home stuff. Heck, you can watch movies over your VPN and stuff like that if you're at a coffee shop with good internet and your home has good internet. But you can do all kinds of stuff. You can make your home accessible at the touch of your fingertips from your cell phone even. And like if there's something that you want to watch from home or monitor from home, or you want to take care of your networking from home, you just set up a VPN on this thing for both security purposes and accessibility purposes. So many benefits come from doing that you'll just be really happy you did that. Now, some other things to know about the Pi-hole is since it works with DNS, it's technically one of its big marketing points is that it can be used as a network-wide ad blocker, because ads, it's traffic. This thing monitors traffic, but you can do things with it. You can block the traffic too, which means you can also block websites. You can block all kinds of stuff as long as it goes through DNS, which websites have use DNS. And we can see right here how many queries have run from the traffic going on, and so I can see kind of like how busy we've been in terms of like we've been working a lot, have we been using the internet a lot for other reasons. You can see generally like it's less active from 2 a.m. to 10 a.m. So you can tell it's not much going on in our world during this time, but you can see that we are very active around like noon to this time, and then we kind of stay a little active throughout the day. But blocking ads also blocks phishing ads, and so if you have family members and stuff like that who or roommates or other people who you live with who click on ads and get infected all the time and stuff like that, this is a good way to secure phishing a little better. It's not going to block everything, but there's a difference between blocking 70% of the ads that come in versus 0% of the ads that come in. And better yet, anything that's coming in, because you're a cybersecurity professional, you can get into some of these advanced features, and you can go over to the blacklist right here, and I teach regular expressions and stuff like that, but you can use regular expressions to start blocking traffic. I don't want to show too much of this because it shows my actual real traffic, and that's a privacy thing, and I'm not that no. So you don't get to see my stuff, but you get to see that there's a, if you learn regex, then you can come in here and start setting up custom ad blocking and stuff like that, and all kinds of custom stuff. And their website has some even cooler options for those of you who are very serious and really want to learn this stuff. One outstanding thing that Pi-hole as a company makes available, I'm not even advertising for them. This is actually just super helpful. This is not a marketing thing. Someone else who works with us discovered the Pi-hole and was like, "This is awesome. Like, you need to check this out." I was like, "Wait, what?" So I took a look at it. I'm like, "Oh my gosh, this is like an enterprise tool without being an enterprise tool." So if you go to their website, there's something in here that matters. If I can find it. If I can't find it quickly, I'll give up. So you can see they make their money from donations, so that's convenient, so that it's affordable. People can use it. Well, either way, I might not... Oh, this is what I was looking for. Oh, this is awesome. Okay, so like you can develop apps for the Pi-hole too to also further your home SOC, because we want to allow our community to build great products for the Pi-hole. And so, like, I'm going to probably come up with some projects that I'd like to build here too, because then I can submit that, and it's just like an easy way to like expand my stuff in a way that other people can access. And you guys can do the same and learn this way. And to talk about a portfolio, let's say that you're a technical person, you're like, "Oh man, yeah, I want to show people that I can do all this cool stuff." If you've been making all these Pi-hole apps and stuff like that, like, "Hey, check out all this cool stuff I made." That's what people want to see. So like if you're having trouble getting a job and things like that, employers want to see that you can apply your knowledge. A lot of people have knowledge, but one of the challenges, a lot of people don't know how to apply their knowledge. And so it's like, you might know Python, you might need Python on like 6 very minor tasks that take up like 10% of the entire experience here. Not to undermine the value of Python, because if you know Python, you can create very custom things, and then like you could start writing like your own little tools and stuff like that, and start to sharpen and refine those skills, and then find ways to make your Python skills more valuable. So it's not about Python skills being valuable or not valuable. It's about figuring out where your skills are applicable. And when you don't know where your skills are applicable, it's hard to tell a person at a company that you know anything valuable. As a matter of fact, it's even hard to understand how you might even know anything remotely valuable. So that hopefully gives you a lot of information about what I'm working on and how this stuff works. And I guess I should give you like the end result of what these things look like. Like, this stuff is so that, like, what does it look like? At the end of the day, you get graphs and stuff. It's not that far off from like the pie hole. Let's see. I'll show that another day. We can get it, because that's a whole nother thing, talking about like analytics and stuff. But dashboards show, it's like, let's say that I want to know anytime there is, say, like a potentially malicious query that made it through the filter, and I want alerts on that sort of thing. And then let's say that I want to know when someone potentially also clicked on that malicious query, and then I also want alerts on when there's like unexpected lateral movement in my network. The logs from the pie hole can be sent over to ElkStack to create alerts around certain things. Or like, let's say that you one day have like an unexpected spike of activity, and you want to get alerts when there's like a very unexpected spike of activity. If you're a business, that could imply something like a DDoS attack, and you'd probably want an alert on that. So you use the other pie to set up the alerting, and this to kind of start setting up like, what are you looking for? What are you worried about? What do you want to be safe from? What bothers you? Like, you could set up things to very specifically to be like, I want to get a cell phone text anytime something unexpected accesses the baby monitor, or anytime someone comes to passes the front door Ring camera past 10 p.m. so that I know if there's like people outside of my house at strange times, which it could be very suspicious. And then maybe you set up motion sensors, and you set up alerts that say during certain times, if there's a certain activity in certain parts of the house or even outside, I want to know. I want alerts. And while it could just be only one time in a 2-year span, let's say that 2 years you never have anything happen, but all of a sudden someone's like snooping around your house and you get robbed. Well, if you have SIEM, you can collect all the information. You can figure out what part of the house they came to first. Let's say you went on vacation. And you come home and you've been robbed. Like, so much stuff is gone. It's awful. You didn't expect it. And there was a YouTube thing. I don't know if anyone watches PewDiePie, but this happened to PewDiePie, and he had an in-home camera and saw the person coming into his home and taking the stuff and things like that. And then they came back and some stuff was missing. And while nothing dangerous necessarily ended up happening, the thing is, there's someone in your house. There's like, and you don't know. You have no idea. And there's something about that it is dangerous and can be uncomfortable. And I've been robbed, and I've had things happen to me and stuff like that. You can avoid some of these things in ways that you haven't been able to in the past. So you can set it up to where, like, you're on vacation, you can have a text come to your cell phone when certain types of activity show up on your cell phone, and then because you set this up with your VPN to be accessible from your cell phone, you can look right then and there to see exactly where they first came in. You can see the motion sensor activities around the windows that you set up. You can see what part of the house they came in. You can figure out what rooms they went into if you have motion sensors everywhere, and then also you can figure out, and that's just like physical security using cybersecurity. And then let's say that you just want to know cyber defense. Let's say that you're not even worried about people coming. You want to look out for the hackers. you can have notifications for the things that people are accessing, and people accessing like certain computers and systems in your house. And like an alert, let's say that you have multiple people living with you once again, and you want to know when someone else that you live with potentially got hacked, so that you can help clean the virus off of their thing so that you don't get the virus, because viruses can spread to your computer from other people. And so just so many things can be avoided by just setting up some things. And once it's set up, all you have to do is just make sure it's running. You build it, you make sure it's running, and then like you want to monitor and update it, because you might find that there's some things you haven't been looking for that you should start looking for. But everything that you've set up at least once in the past, you can back it up in case something happens and you need to rebuild it or something like that. Back up your operating systems. There are ways to back it up. I can talk about that. And you need to make sure you have a lot of storage and things like that. There's NASs and things like that to manage the data. And you just set it up, turn it on, and it's only a lot of work in the beginning, and then forevermore for the next 2, 3, 4, 5 years with a little, upkeep, then you always know what's going on with your electronics. And when you're on vacation, you can get notifications about people snooping around your house, and you can pick up trails on exactly how it happened, and you can really have some serious control over your life and your home, and in terms of safety, and not be scared of smart home devices. You don't have to be scared of smart home devices. Just watch them, monitor them. Don't panic about it. You don't have to be paranoid. You don't have to be paranoid. Don't be paranoid. Don't be paranoid. And that's the lesson of the day. I hope you guys enjoyed this long, educational video, and I hope you learned something, and I hope it wasn't too boring. Please give me some feedback and let me know what you guys think of this kind of stuff. If no one watches this, I'm probably not going to make a whole lot of videos like this, because it's a lot of work, it's a lot of information, and it's a waste of my time if it's a waste of your time if no one's watching this. So, yeah. So thanks again. And subscribe if this is the sort of thing that you like, and if the type of stuff that I talk about is interesting to you. And if you don't, then don't subscribe. And if you like this kind of content, give me a thumbs up and a like so that I know that this is helpful. And if it's not helpful, give me a thumbs down, and then I'll know that it's not helpful too. So if I end up with like 30 thumbs downs and 2 thumbs ups, I'm just not going to make more videos like this. If I end up with like a bunch of thumbs ups and feedback that this is cool, and then I'll keep making videos like this and stuff like that. So thank you guys, and I hope you're all having a great day. I'm going to go ahead and end this. And stay safe. Stay safe out there.